Hello everyone, I am Sahajleen Kaur. Today I am going to explain my major data science and analytics project provided by Pregrad, which is based on linear regression model. The main idea of this project is to analyze data and make prediction using linear regression model. Linear regression helps to find a straight line relationship between variables and use that line to make prediction. And this I built a regression model using Python in Google Colab. Then we'll move to the task 1. Here I imported all the required libraries such as Pandas to work with data, NumPy which is used for calculations, Matplotlib and Seaborn to create graphs, etc. Then we'll move to the task 2. Here I loaded the data. To read the file and load the data into data frame, pd.read is used. Then the head command is used to view first few rows. Like in this, I used head 10 to view first 10 rows of a data which include TV, radio, newspaper and sales. Info command is used to make sure that all data points are numerical and there are not any null value or any missing value. Then we'll move to the task 3. Here relationship between features which are TV, radio, newspaper and responses which is sales are shown. It basically tells that how change in features correspond to the change in output. Like in this case, TV versus sales, positive correlation is shown as pattern of dots are less scattered and more linear. Then in case of radio versus sales, it shows moderate positive relationship as pattern of dots are more scattered than TV. Then in newspaper versus sales, it shows weak or no clear relationship as pattern of dots are random and more scattered. Now we'll move to the task 4. I developed a multiple linear regression model to see the effect of TV, newspaper, radio on sales. And this as it shows the negative coefficient of newspaper, which means it has minimal effect on sales, and on the other side radio and TV has positive coefficient, which means that it leads to higher sales. Out of these two, radio has strongest influence on sales. Then we also have heat map which shows +1, which means it has perfect positive correlation. We can see that versus TV and sales, we can see that it has strong correlation of about 0.78, and then radio versus sales, it has moderate positive correlation of about 0.58. Then in case of newspaper and sales, it has weak positive correlation. Then we'll move to the task 5. In this, feature selection is performed. The multiple linear regression, which is trained by using only TV and radio as predictor, which is model 1, and we also have model 2, which includes 3 features, that is TV, radio and newspaper. Here we can see that R square score of TV radio, and then from model 1, and then from the model 2 the score of R square, it only has a minor difference in these two values, which shows that newspaper doesn't add any useful prediction information beyond TV and radio. Now we'll move to the task 6, which is model evaluation using train and test dataset. Basically, here we are checking whether to use newspaper as a feature or not. As here we can see the RMSE value of the first, where we used newspaper. We included newspaper with the other features and the R square value of this. And then next we also see the R square value is 0.915 and the RMSE value is 1.4046, which is much lower here, as here we are not using newspaper, we are dropping newspaper from the features. So here we can see that the RMSE value is much lower and the R square value is much higher than before, which indicates that the lower value of the RMSE indicate low error and the higher value of R square indicates explanatory power, higher explanatory power. And then we'll move to the task 7. It shows the prediction error plot. It compares actual sales value with the model predicted value. Here we can see that the data points are closely matches as they are very close to the identity line. So now we'll move to the task 8, interaction effect. In task 8, interaction effect of TV and radio advertising is seen by multiplying their budget to see if they produce synergy effect. And this we can see that there's much lower value of RMSE of about 0.701 and a higher score of R square, which is 0.979 value compared to the model without interaction. It basically shows that interaction effect has as advertising on sales is much stronger than their individual effect. Here, prediction error plot is used to visually evaluate the performance of interaction model. The plot compares actual sales with the predicted sales. As most of the points lies very close to the identity line, it confirms higher accuracy and strong interaction model. So in the end, this project helps me to understand how data can be analyzed and used to make prediction. The project strengthened my foundation in data science and machine learning concept. So thank you.